I think it would make you crazy.
Probably not to be used for long periods of time.
Welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 238. This week we'll be talking vibrating bowl feeders, open Sourcery, and learning to love the layer lines. In the news this week, a big old chunk of asteroid landed in the Utah desert.
Intentionally, too.
On purpose.
Yeah. Do not be alarmed.
With the parachute attached.
No, it's very cool. We covered when they captured the sample. There was some drama about whether it was going to work or not. A pretty cool system of, like, it touched touched down and shot gas or something out the arm, and it collected everything that flew out into, it turns out it's not as easy as you might think to get a piece of a deep space object without, crashing into it. And then, they had to fly the samples back, and it's always a little tricky to re-enter the atmosphere, especially with something so small. I mean, it's like like the size of a suitcase.
Yeah, it's really cute.
If you didn't watch like the video when it came down and then they actually go out there and start messing with it, you might think it's like some Apollo capsule or something. It's super small. It's like just big enough to carry the heat shield and samples, right? Like you have to remember this thing had to go all the way out to deep space and all the way back, and the rocket equation is very unforgiving, so there wasn't a lot of excess mass to play with. Like, it really had to be the absolute bare minimum for a recovery vehicle, and bare minimum is bare minimum, so there was always a chance it wasn't gonna go well. And in fact, a previous attempt crashed, right? I forget which one that was, but there was years ago a similar attempt, and it didn't survive intact. All went well this time, though, and it should be interesting to see what the results are and study this, deep space structures. And there's, a lot of questions what the stuff is made out of, and if we ever have to deflect one. That's a big question. If we ever have to like deflect some deep space asteroid or something, what is it made of? That might be helpful if we have to break it into smaller pieces.
I was watching it land live, and I'm not the world's biggest space geek. That would be you, actually. And but I saw somebody posted up on the Hackaday Discord that the thing was landing right now. And I'm like, oh, well, hell, I'll watch the NASA live feed. And sure enough, orange parachute thing falling down. They went to go find it. And that was the funniest part to me, because there they were. They knew basically where it was. They had a helicopter, so they had eyes on it. And they had this like picture of this big orange parachute on the ground. And then the people have to go out and drive to it and pick it up. And it totally reminded me of like picking up high altitude balloon payloads. It has the same sort of feeling to it. Like, where the thing is, you just have to go schlep on out there and pick up your package that's been to deep space / the upper atmosphere, depending on which you're in. They're also totally cheating because they knew exactly where the thing was because they had a helicopter.
It looked like it landed right next to a road, which was super helpful too. Like,
yeah, exactly.
I know
the chances. Didn't get hung up on a power line,
right? When it came down, I was like, "Is it sitting right next to the road?" I mean, like, I know because there's a pretty large like ellipsis that it can come down in. I mean, to land within walking distance of a service road was very helpful.
That's pretty sweet. Yeah, I'm sure they planned it. Of course, we get asteroid bits fall to Earth all the time, right? We get meteorites, but the difference in the science there is that the only parts we get in the form of meteorites are the super hard parts in the middle. And these asteroids are probably, who knows what they are? They're random conglomerations of God knows what. All the rocks that have been floating out there and kind of gravitationally accreted. So nobody knows what it's going to be like. It's actually really, really cool to think that this is the first time you're going to get unburned asteroid samples back to the Earth.
Market fresh, nothing burned.
Without all that melted iron on the outside of them. That's going to be fun. Can't wait to see what it looks like. My guess, it's dusty and rocky.
Safe bet.
You heard it here first. Asteroids are dusty rocks. And if you're thinking about coming to SuperCon, get yourself some tickets now. SuperCon, my God, it's coming right up. It's the first weekend in November. We haven't even announced talks yet. we've got them selected. It's a super lineup, so I can't say too much about that. We'll be planning to announce the talks over the next few weeks, also the workshops. So when that comes around, that will be your chance to sign up for them. Workshops always go super fast. So, and we heard from Hackaday super friend Kenneth Finnegan that the hacker train is going to be on again. We'll post the links in the show notes. This is a train where everybody going on down to Hackaday tries to get in on the same car and all hang out together. It's a super pre-party and possibly even post-party. I don't know how that part's arranged before SuperCon. But if you live anywhere from like Seattle all the way down to Los Angeles, you can catch this train and join up with them. I'll put the links in the show notes. Go join. They seem like they have a really super good time.
Yeah, it's actually what do they call it? Coast Starlight, like a scenic route down the whole West Coast. So I mean, even if it wasn't for the fact that people will be soldering and stuff in the train, it sounds
nobody
like
will be soldering in the train.
It sounds like it'll be a cool ride, regardless.
Yeah, it's for sure, for sure. And then that brings us to what's that sound?
This is a journey into sound.
What's that sound?
What's that sound?
This week is a Guess the Sound challenge,
Of course
and
it is.
Tom Nardi, you are in the metaphorical hot seat.
This is something.
That's right, it is. Correct, you win.
Yay! Digital encoding of something.
Data? Yep.
I think we did something similar, right? And I thought at the time it was like a pager or something.
Right, right.
But it was not. So I have nothing more specific than digital encoding over radio or something like that.
Can I give you a hint?
Okay.
Did you listen to the show last week?
I thought I did. Is it something we talked about on the show last week?
It's related to something we talked about on the show last week. Let's see.
Talk about a lot of things.
We talk about a lot. Yeah, fair enough. Another hint, there's kind of a regular bleepy pattern in there.
Oh, really?
And the last hint is there's a dropout.
Oh, hold on. Listen again.
Have a listen again if you want.
Oh, yeah, there kind of is a...
See what I mean?
Yeah.
But if you didn't go down the same rabbit hole I did last week,
so,
you
I
might not have it. This might not be any help whatsoever.
I did hear the repeating part of it that time, but no, I still don't know exactly what it is.
All right. Well, if you listeners out there know what it is, then head on over to hackaday.com/podcast. Fill out the form, and you'll be in the running for a Hackaday podcast t-shirt next week. All right. Well, my first hack this week takes us to France. Feed your fasteners in line with a bowl feeder. And I don't know if you people have seen bowl feeders. This is a piece of usually industrial equipment that kind of vibrating bowl feeder. It kind of shakes, and then it's got a little spirally ramp up the outside. And by vibrating the parts just right, they all kind of sort themselves out into a single file line and neatly, almost magically, progress up the spiral ramp until they come out. The magic that makes them work is actually kind of asymmetric springs. And so you get this kind of, hucking the parts a little bit, and they kind of jump their way around. They're really fantastic to watch and extraordinarily expensive, I guess, because normally they're like, super industrial machines. And so that's what I thought was super cool about this, is that France took it on himself to 3D print and then otherwise manufacture one of these things. He says in his write-up, the principle is relatively simple when viewed from the outside. The development of the vibrating bowl feeder system, however, took over 3 months and consumed 200 to 300 working hours. This was not what I had expected.
It never is. I'm glad you said about magic, because it definitely looks like witchcraft to me. It actually reminds me of Fantasia or whatever.
Yeah,
when Mickey's
right?
making the making the mops and brooms dance around, and because they do all the screws just kind of like, oh, I guess we're in line now. I guess we're soldiers, and they just kind of do their thing.
Settle out, get on the ramp, and go on up.
Off to work we go. I'm really glad, the video is cool, but I'm really glad that there's actually like a write-up that goes deeper into it. You might be forgiven for just watching the video and thinking, that was it, right? Because it's most impressive in motion. But in the write-up and seeing like the different versions and like the test rigs and stuff and how much research went into it, like I said, hundreds of hours of work seems about right.
Yeah.
There's a detail. I don't even know if you can see it in the video. It might get kind of glossed over, but like there's a really heavy base is necessary, I suppose, because the thing's bouncing around and you don't want it to bounce off the table. So the 3D printed base is hollow and there's concrete in it, but also just like crap. Like anything like that was loose that you could find. There's all kinds of bolts and just pieces of metal and stuff just thrown into the bottom of this thing and then encased in concrete to add, as much weight as possible to hold this thing down. So it's cool details, rough cut of the final machine.
Yeah, and making this thing go is all about tuning it. And apparently, like, you have to match the spring strength to the strength of the electromagnet that's pulling it down in the middle. And then you have to get the frequency of doing this just right. A, for your parts, but B, so that it matches kind of the vibrational frequency of the bowl thing. He ends up gluing what looks like rubber mat or something up the spiral ramp so that things don't, so that they don't slip backwards as they're moving on up. He puts some kind of a matte black spray all around the inside, which he says is important. At first, he's just using an electromagnet and kicking it on and off with a MOSFET, but then he discovers that you actually need to pull back the other way with the magnet to damp it down fast enough so that the things get really thrown. And to do that, you need a bipolar thing. So he's got like a stepper driver instead of just an on-off switch. He ends up learning how to do direct digital synthesis to make a nice sine wave on his Arduino that's driving the whole thing. Like there's a ton of super cool detail here. And then, like you said, the video is awesome and magical to watch. And I don't think any of us can get mad at France for spending the last 5 minutes of the video just celebrating how the darn thing works. And you can see it like moving like bolts up the magic ramp and Legos, and eventually he does it with some radish seeds. I mean, he's just taking everything small in his house and pouring it into this thing and watching it scoot on up. So I think that's really awesome. And this totally reminds me of the video series by Christopher Helmke, where he's been building similar machines to dispense like 60 bolts or separate nuts and stuff like this that he's using for a small run 3D printed kit manufacturing business. And that's also the sort of application I could see somebody wanting a bowl feeder for. So it's really neat to see this kind of previously prohibitive industrial machinery type stuff being made by people with 3D prints. And, granted, France also has a lot of cement in it, but, being made by the home gamer. And I just love seeing these machines being replicated. So good on them.
For the record, as we were talking about this, I went on eBay, and these things are not cheap. So if you're ever thinking like, it's not worth the effort, you're saving. Like, I think they start at like $500-$600 and kind of go up from there. So, and those are used and probably giant, dusty things that you don't want in your workspace. So it's worth some filament and some time on the Arduino. Well, my first one for this week is getting shredded plastic and legs. This is a project out of Precious Plastics, which, if you're not familiar, they have a pretty long track record of making maybe whimsical is the right term, devices for recycling plastics. I mean, I think we've seen like injection molding stuff and basically finding innovative ways to reuse plastic without, industrial overhead that would usually require. And in this case, true to that goal, they've modified an exercise bike to shred plastic. And the idea here is that if you're somewhere off grid or whatever, there's no readily available electricity, you could jump on the bike, throw some garbage in there, and pedal your way to nice shredded material to whatever. It's not like, you're pedaling and drinking glasses come out the other side. Like this is just, one element to a larger goal of like hyper local recycling. And you can imagine somebody with a 3D printer could set something like this up, and this is their lunch break exercise routine. They grind up their old prints and turn it into new filament. And it's always really cool to see what the precious plastics people come up with.
One of their motivating goals is to like get the value of the plastic closer to the people who would be otherwise throwing them away, so that every time you throw away the bag, you think, oh man, I could have kept that and melted it down for my plastic bricks or whatever it is I'm making with them. I kind of see that. I kind of buy it.
But there was kind of a secondary reason I wanted to talk about this one. Precious plastics, their MO is to make these designs open. They, generally speaking, use Creative Commons to release their designs. But they've been doing a thing where there's a exclusivity period where only their Patreon subscribers can get some of the designs. They use this to help fund the overall project, but the intention is always to, once that period ends, they're gonna, it gets released, and then it's, once it's in the wild under Creative Commons, obviously it's out there forever. You can't put the genie back in the bottle, right? And when we wrote this one up, that's what we said. Hey, it's open source, but there's this exclusivity period, and some people they took some took offense to this because they were saying, well, if there's an exclusivity period, that in itself means it's not open source. And that's an interesting observation. And I would say if it wasn't for the fact that Precious Plastics maybe has a track record, right? We've covered a bunch of their projects. We see how they operate. They have kind of like an explainer on the website, why they do this. Maybe we would have been a little more careful with how it was phrased. But I mean, I know personally, I am confident that they will stick to their MO and do what they always do and release it, as an open source project once they're done with this. I kind of look at it as almost like a private beta test. In my mind, distribution hasn't happened, right? And so, most of the open source licenses, specifically like Creative Commons, it's like once it's been distributed, it's out there, but it hasn't really been publicly distributed because it's still within the group. So I kind of liken it. I liken it to, imagine if we had developed some kind of open source tool, right? And me and you were bouncing it back and forth between each other, but always with the intention that when we were done with it and we were cool with it, we would put it out there. I kind of look at it like that. It's not developed in the open, but the end result is open, if that makes sense.
Yeah, I think that does.
But I also totally get how, you can look at it and be like, well, you're calling it open source, but I can't get it for 6 months, or I can if I pay, whatever their Patreon thing is. I get both sides of the argument. If it was an individual doing it, I would maybe feel differently about it, but because they're a group and because they need funding, right? Like to further their goals. I don't know. I don't know. It's an interesting thought experiment kind of thing. Like, we should have said they will be open source instead of they are open source, which is
right.
Quite a hair to split, but these are the readers of Hackaday. So we should come to expect that by now.
The whole point of the Precious Plastics group is to get these designs out there so that people can make them and contribute new machine designs and improved machine designs. And so, yeah, in that sense, I'm totally with you. I don't have any worries that it's going to be eventually released because, that's their whole game. Like, that's right. The whole point of the whole endeavor anyway. On the other hand, you can look at these things, right? I mean, it's a shredder and some bolted plates and...
Yeah.
There's nothing particularly secret about this design either, I think.
And then this also gets kind of into a larger debate about is the whole concept of open source super applicable to hardware like this? Because like you said, I can kind of look at this and get most of it from the picture, right? And what are we talking about? Some DXF files for sheet metal and stuff. There literally is no source code because there's not even an electronic component. Like, this is a foot-powered grinding machine. So I don't, it's not like I need a firmware or there's no Gerbers, like, so it's a weird, even calling it open source is maybe ill-fitting, but I guess what else do you call it? Even open hardware is kind of
They're going to make the plans available and they want you to contribute back. I mean, that is kind of the whole essence of open source software. So I do think in that sense, I'm putting the code out there and I think it'd be awesome if you help me make it better is kind of the basic spirit. And I think in that sense, it's totally right on. But I don't know. I'm not the hair splitter when it comes to.
Yeah, these are very large, philosophical debates to be having over a exercise bike with a plastic shredder on the front.
My next hack comes to us from Mitsela. I haven't seen a hack from him in ages, but he's secretly one of my favorite hackers. He does some really great synthesizer hacks, tiny stuff hacks. This one is the reverse oscilloscope, and it is an arbitrary waveform generator synthesizer. And if you don't know what that means, it's a box that makes a lot of funny noises. You should go check out his video. This particular one, it's got 16 illuminated sliders on it, and you can slide them up or down, and whatever shape they trace out is the waveform that gets played. And that's really cool. When it's set on its kind of full digitaliness, it sounds wonderful and abrasive. And he's also got a mode where he can smooth in between the 16 points. And there you can make it sound, very kind of warm and analog and, low pass filtered, if you know what I mean. Anyway, the point is he has done a fantastic job with the design of this thing. And I'm a longtime DIY synthesizer nerd, so I actually really appreciate some of the design details here.
I like how seemingly half of the comments are like, "This is a waveform generator." Like, yes,
yes, it is.
Yes, you're right. Thank you for as if we didn't know what that was. You know what I mean? Like,
yeah, right.
But I mean, this is the most arbitrary waveform generator. Like you've heard of the arbitrary waveform generator. This is a super arbitrary one.
That's right.
It's not just you picking between square and sawtooth. You can really shape it however you want. So I mean, obviously there's a lot more creativity involved here. I don't think this is a piece of test equipment anybody's going to be using in the lab.
I mean, it kind of started as a joke. A long time ago, he wrote a software application that did exactly this. And then this is kind of the hardware embodiment of an old app he had. And what's funny there is that, of course, when he was doing it in software, he could be like, oh, we need a knob to control this and a knob to control that and more buttons to control this. And, when you're doing software, there's no cost to adding more features except, you're overloading the poor user. Whereas when you do this in hardware, how many knobs do you have in your part box? That's the maximum number of knobs you can put on it, right? And every one of them you have to solder up to something. And it's just, eventually you run out of GPIO pins. I mean, there's all these kind of real world constraints. And so it's kind of fun to see him talking about that in this video. And at the very end, you should really check out the reveal. The front panel is a really nice laser cut front panel, but then he opens the box and it is just full of bullshit. And he kind of warns us about this before he does it. He says, I ran short of time, blah, blah, blah. I cut every corner I possibly could. And so he opens it and there's a teensy doing the hardcore DSP stuff. There's a Pi Pico doing interfacing between all of the potentiometers and stuff and the teensy. And then he's also got an old Atmel AVR chip in there just to handle blinking the lights because all of this stuff was on his shelf and it was the quickest way to bundle all this stuff together. So he takes this fantastic sounding and, not bad looking on the outside synthesizer, opens it up, and on the inside, it's a bunch of microcontroller dev boards taped with masking tape to the inside of this box. And if you want to read more about how the DSP and stuff works, you've got to go over to his website because he actually does explain a lot about how this thing works on the inside, where basically it's all code.
I think I want to make a warning sticker. It says warning device contains bullshit.
Yeah, right.
I'll just stick that to everything I make.
BitLooney came in actually and said, he made one of these with an Arduino 10 years ago. And I'm trying to think, I know for a fact that I've seen one made out of old analog electronics from probably the 90s even. So probably 30 years ago. It's an awesome old idea to make different noises by doing a bunch of sliders, and it's a fantastic and intuitive interface, and I guess I just like to see it done again. But yes, reverse oscilloscope, that is not the technical term for it. Technically, it's an arbitrary waveform generator.
All right, now for this one, I really went the full spectrum. I edited this one, I guess, last night, and I almost didn't even want to run it on the site. So went from not wanting to run it to running it, and then now talking about it on the podcast, because I thought it was such a ridiculous thing. I mean, I guess I at least have to give them credit for the solution here. So, all right, this one is about the lid sensor in new MacBooks that apparently, unlike every other laptop since the beginning of time, instead of just sensing when the lid is closed and going to sleep, this now senses the angle of the lid. So it's not just like a simple lid is closed. There's an angle, and then it has to be calibrated. And you can only calibrate it like with Apple's tool. Like, it sounds ridiculous. It sounds like it's a joke. Like if I was reading this, April, I'd be like, this isn't real. It can't possibly be real that there's an angle sensor on the screen that it needs to be calibrated and can only be calibrated with proprietary stuff. But this is the life. I couldn't tell you how many laptops I've had in my life. None of them have ever like failed to detect when they were closed. So like, how is it so common that they have to actually replace these sensors that this is a big deal? Like, all right, whatever. That's a whole side thing.
Cha-ching.
More surreal elements to it. But fine. So since 2019, they've been putting these sensors in here. They're enough of a failure point that it's been a big deal that people can't change them on their own. So now someone has come out with a little hardware gadget that you can plug into the motherboard, and it like sits between the sensor and it can calibrate it. And the thing costs $180, which like I have whole laptops that didn't cost $180. Like, right. So $180 just to calibrate your lid sensor, and people are eating it up because that's cheaper than the official repair from Apple. And like, the whole thing is,
y'all need to calibrate your lid sensors if you're paying that much money.
It's like I gotta change my wiper fluid, right? Like, it sounds like gibberish words, but no, this is the real stuff. And I originally was kind of hoping like, okay, well, at least they've defeated this thing and now it's out there in the wild and it's open source, but it's not. It's kind of ironic because we were just talking about open source, and people's intent and stuff. If they sell 350 of these things, they will then open source the design. And like, that bothers me way more than the other thing, because that's, to me, it's kind of like you're holding this idea hostage. Like, you have like, so if you only sell 348, you tell me you're not gonna release it. More hairs to split, right? But the whole thing is super weird to me, and I just can't understand why someone would voluntarily submit to this kind of treatment from your hardware manufacturer. Like, I don't know.
It's because they make really sweet laptops, and then they put these Achilles heels in them, so that you have to then go pay the genius at the Genius Bar to get it fixed for you.
It have to be pretty sweet, to deal with this, like, such antagonistic treatment by the person you gave a lot of money to, right? You can't even get a MacBook for what I would consider a reasonable amount of money.
I love the idea of using an accelerometer. Like, accelerometers used to be expensive, and now they're so cheap that they're using it for a purpose where it's not even well suited at all. Like, figuring out whether your lid is closed. Like, does this mean it has another accelerometer in the body of the laptop? I mean, the lid's only closed when it's flat, when the laptop is horizontal on your lap. If the laptop's upside down, or sideways in your backpack.
Yeah, sure. you would need to know like
does
the
it,
resting state of the body.
so they must also have another angle detector on in the laptop body itself, so they can say, are these two at the same angle? Well, then it's closed. If
And
they're
like
not at the
calculate the
same angle,
difference
then
between.
it's,
Oh man,
like,
and
I can't imagine the need to design this thing, and it's just so like it's so over the top crazy to begin with that like.
And in the write up, it says like Apple's official reason for the increased level of precision. Like, it's kind of a binary thing. Is it closed or is it open? Like, I've never been like, is my laptop half closed? Like, I've never once wondered that, or had
My
a reason
laptop has
for it to
never
be half
wondered
up.
that either.
Yeah, right. It's
Like, my
it's
laptop
closed or it's open.
knows it's closed somehow. I actually don't even know how. It must have a magnet and a Hall effect sensor, but actually I don't know how my laptop knows when it's closed.
Yeah, right. Because it's worked forever, and you never had to replace it or calibrate it, so you never gave it any thought. You know what I mean?
Jeez.
But if you have a 2019 or newer MacBook, you're going to be thinking about it a lot. And if you weren't thinking about it before, you're thinking about it now.
If you want to calibrate an accelerometer, you put the thing on a known level surface and you read that value. Like, there you go, done, right? Like, I've calibrated 1 million accelerometers. You just leave the thing sitting flat on the table and you don't do anything. They could do that in software.
Yeah, you could do that. Like, the operating system could certainly do this.
Yeah.
Just take the feeds from the two angle sensors and then figure out I mean, the operating system's got to figure out when to go to sleep anyway, right? So,
Yep.
but then they couldn't sell you a calibration service, I guess. Like, wow. If you're out there and you have one of these things, you have my sympathies. That's all I can say.
Next up is process threads and fibers. This is a long talk about different levels of multi-processing and multi-threading and scheduling and computer programming stuff from a graphics guy. And it's really neat because he couches this in terms of video game development, but it's actually just as relevant for programming on microcontrollers and other small systems and basically anywhere where you're trying to get that last little bit of performance out of the system. And fibers is what he's talking about. And if you don't know about how multitasking systems work, here we go in 28 seconds. I'm a hardware guy, layman's take on the whole thing. One CPU can't really do multiple things at once. So what it does is it spends some time on this one, stashes it, spends some time on that one, spends some time on the next one. And so then that gives you multitasking. Once you start getting multiple processors in there, how you split these various tasks up amongst the various processors and then giving them all slices in time is where you get into threads. In the system that graphics guy is pushing here, the even smaller level of task scheduling he's calling fibers. And these are really interesting. The switching in almost every operating system, the switching between the processes and threads is done on kind of with a preemptive scheduler. So it says, okay, this process gets some time now. Okay, now this one does, now this one does, now this one does. This is in opposition to cooperative scheduling, where you have each of the different subprograms say, okay, I can give up some time now, let the next one run. And this is how proto-threads or coroutines, or in Python, the async IO library works. It's this kind of application level cooperative scheduling where it's up to you, the coder, to say, okay, here I'm just waiting for user input anyway. I'll yield some time to another process, and then the program can run this other task for a little while. But as a hardware guy, I will say that I absolutely love this cooperative scheduling, proto-threads, coroutines, fibers, async IO model. Because when you have constrained resources, a lot of the time you're saying, here's some super timing critical stuff. And if you have an interrupt-driven or a preemptive scheduling operating system going on there, you have to be very careful to say, this is a critical section, don't interrupt me while I'm in this critical section. And then let the preemptive scheduler pick up whenever it wants otherwise. Whereas cooperative scheduling is kind of the like opt-in versus opt-out version of this. With cooperative scheduling, you're saying, okay, now I have some time, feel free to interrupt me now and do something else. And the difference there is that for me anyway, as a bad programmer, with preemptive scheduling, I find myself having to defend against all of these possible gotchas that could happen when the OS takes control away from me and destroys my program flow where I thought I knew what was going on. Whereas with cooperative scheduling, it's like, oh, here's a good time to yield. Type yield, enter. The first time it ever bit me was using an old AVR, and there's a bunch of 16-bit operations that take multiple cycles. And if you get an ISR, an interrupt subroutine, come in the middle of writing the two different bytes in a 16-bit number, it can change the number out from under you while you've written half of it and are about to write the other half of it. And if you are doing a lot of microcontroller programming and you're thinking, maybe I need an RTOS, maybe I don't, if you're on the fence there and you don't want to jump all the way in, something like a little cooperative scheduler, like in this proposed fibers thing here or in coroutines in C++, protothreads in C, might be what you're looking for. So check it out. You'll probably enjoy it.
Listen, all I'm going to say about this is this is why they just started adding more CPUs to modern devices.
Tell you what.
Because nobody wants to figure out how to do multi-threading. It is there be dragons for sure.
Yeah, real multi-threading gets really complicated when the two threads need to talk to each other a lot or share resources or whatever like that. You have to be able to be sure that the tasks running on the one processor and the tasks running on the other processor don't write to the UART at the same time, or they don't, overwrite each other in memory and stuff. And that's where it gets tricky. You don't have that problem with coroutines / protothreads / fibers because there you're explicitly saying, okay, I'm done in this function. I can take a pause, let another function run. And so you actually avoid this whole problem of contested resources because you, the programmer, know when it's time to give up control and regain control. And that's actually super handy. The reason it fell out of favor in big operating systems, though, is that, imagine someone writes a piece of crappy code that never yields, right? That just brings your whole operating system down because that one piece of code then hogs all of the system resources. So writing routines to work in a cooperative scheduler requires cooperation. It really does require the programmer to make their best effort to give up time as often as possible, but no more often. For small microcontroller projects, it really feels to me like that's the right level of multitasking because you miss all of the shared memory, shared resources gotchas, and you get that, apparently three things are happening at once effect.
Now, this next one I picked because it's a topic that's near and dear to me, or at least was, and that's kind of what I wanted to bring it up for. This is Powder Your Prints for Baby Smoothness, which is kind of a weird title now that I read it out loud. This comes from Dave Rigg, and the idea here is that you mix UV resin with baby powder until you get a goop. Well, actually, thinner. They talk about like almost a milky kind of consistency, and then you paint your 3D print with it, and you cure it in your UV box, which of course you have because you're reading and listening to Hackaday. And the result is a smooth print, more or less. There's still probably going to be some sanding involved, but it'll go a long way to filling out the layer lines. It reminded me that when I first got a 3D printer, I was super obsessed with smoothing out the prints. And we're looking into different ways to do it. And in fact, I actually also wrote an article, now that I think about it, where I was using a 2-part epoxy from Smooth On and filling these lines. And I guess I just don't worry about it anymore. And I kind of was wondering if you had went through a similar kind of, I don't know if I'd call it growth necessarily, but when I first looked at 3D printed stuff, I was like, oh, look, it's I don't like the lines. It looks like it's all, like it's a Lego thing. And now I just kind of, I don't it doesn't bother me anymore. And of course, listen, if you're making a stormtrooper helmet or something, and obviously that needs to be smooth, right? So there's going to be reasons aesthetically that you'd want to smooth out a print to make it look not printed. But I just, at least me, and I feel like I kind of grew out of that concern. And I suppose it's because I do more practical, I would say wholly practical, really, at this point. I don't really do any kind of props or artistic stuff. Like everything I print is a bracket or an enclosure or something like that, where I've either just kind of learned to mitigate the layer lines as much as possible in terms of lowering the layer height or just kind of hiding it in the geometry, or I just don't really care anymore. And it was interesting to look at this and see what legitimately seems like a very promising solution that I just can't seem to get excited about, because I no longer am worried about having super smooth prints. I suppose it's just a matter of how you use these tools and what you thought maybe was important when you got started versus what is important once you actually put these things to applications and start making stuff.
Is this growth or is this defeat? Have you just given up and now you've embraced the layer lines?
It could be. That's why I say growth could be the opposite of what this is. I could very well have just been like, you know what, I'll deal with it. I'll deal with the layer lines. But, I think, and again, if you're making a prop from a movie, it needs to be smooth, right? There's nothing. But I think maybe at some point, even subconsciously, when I started designing stuff, I just kind of said, okay, well, it'll look less layery if I do it this way. Okay, one side's flat on the bed, and I got the textured PEI bed, so that always looks pretty cool. And then you got the flat walls. At a reasonable layer height, you're not going to see a whole bunch of artifacting on a flat wall. And then, maybe I got a front panel or something that could be not even printed at all. So I think just a lot of the stuff I do, I kind of forgot about it, that it was a problem.
Maybe we've been doing 3D prints now and kind of are so used to them that we've accepted the layer lines as being, a part of the thing. Whereas before you were comparing it to injection molded parts or
right.
Parts made with other fabrication methods that are necessarily smooth. And now comes along new 3D printing and you're like, oh crap, it's not smooth. Now that 3D printing's kind of matured, you're not worried about comparing it with these other manufacturing modalities. It is just 3D printed, and 3D printed things have layer lines. They have ridges. Moving on. Maybe?
Yeah, I think you're on the right track, because they had a very alien look when you started, right?
Right, that looks weird.
You're like, what is this? This is super weird. Like, oh, it's cool, but it looks weird. And then weird becomes the norm, as it does. And now it doesn't.
Now you don't even see it. You don't even see the layer lines.
Oh, I'm like Neo. I don't even see the code anymore.
Exactly.
But yeah, I think you're on the right track. I think when you get started, again, this is not everybody necessarily, but at least for me, I loved the idea of 3D printing, but it bothered me that there were these visible layer lines, and I spent a lot of time thinking of ways to get over that, and I just at some point accepted it as a side effect of this construction technique, in the way that I imagine if you use different kind of saw blades on wood, the finish will be different.
I've kind of gone a little bit the other way. I mean, maybe with me it's this U-shaped curve, because I started out 3D printing way back when, we actually had a RepRap Darwin in my hackerspace, and then we got a Cupcake, and both of these were printing with 0.5 millimeter nozzles, which were pretty darn big. And then kind of the industry settled down to 0.35, which is a lot smaller. I can think about some old prints I made back then that had really chunky layer lines. And now if I look at something like, I'm looking at a bike light mounting bracket I made for my son here on my desk right now, and I must be using 0.2 millimeter layer height. It's not that bad, right? It's it's not distractingly layer lined, but I have two printers, and one of them is set up to do test pieces and things I want done fast and strong. And I've got a 0.8 millimeter nozzle in that thing, and it just sets down a bead of plastic. It's like glom, glom, glom. And I made some throwing stars for my son's birthday party a few years back with this because I needed to get them done fast. And it's really awesome. It kind of makes a bevel on the edges for you automatically because the beads are so thick. It's like automatically got a 0.8 millimeter radius on it. Like the layers are thick and chunky and it's strong as all hell. And so I've actually kind of, at least with some things I make, I've kind of started to like the aesthetics of having big visible bead lines that I get out of, printing at whatever it is, 0.6 millimeters high by 0.8 millimeters wide. I mean, that's a chonkin thick piece of plastic. And there's something kind of cool about that too. So
embrace the chunk.
If I were making props that I needed to look like they were shiny, and I mean, we do have to give it up for this, right? Like he mixes baby powder in here, he sands it, he does it again, he sands it, he does it again, he sands it. He paints it with an airbrush in this fantastic shiny acrylic color. I mean, the thing looks like a bowling ball or something.
Yeah, that's exactly what I was going to say.
Perfect sphere with this beautiful pearlescent coat. Like, if that's what you need, this is a way to get it. And I think that's useful too. But I like your take that the chunky layer lines is fine.
You watch like Blade Runner or something, and they have this like cyberpunk aesthetic.
Right.
Maybe this is part of it. The 3D, as we become more used to like these 3D printed parts with very like brutalistic lines, it just becomes what we're used to, and it'll be part of the tapestry of our future.
My first quick hack this week is a Beverage's Law of Headlines. Will nickel hydrogen cells be the energy storage holy grail? No, of course they won't. This is a neat write-up, though, of some battery technology by Bennu. It's nickel hydrogen batteries, and that means that the cathode is actually made out of hydrogen, and these things are in incredible pressure tanks. They're heavy as all hell. Energy density isn't that incredible, difficult to manufacture, but they can be discharged and recharged kind of infinitely. And so this makes these good for grid level storage and seems to be an industrial end use here. But holy grail? I think not. You won't be powering your laptop with one of these anytime soon. 8 billion PSI hydrogen. But next up, just in time for Halloween, Dedi Ruxpin appears alive and well. This is a hack by Hackaday alum Cameron Coward. He has built his own interior animatronic servo motor monster and put a hand puppet around it. The cool thing here is that where Teddy Ruxpin had a mouth that moved by syncing it to the left channel of an audio cassette tape track back in the day, Cameron has arms and legs and eyes that need to move, and he's controlling these by encoding them in different frequencies in the control track, and then doing an FFT on an Arduino to convert this into servo cues in dead E. The E stands for evil, Ruxpin. And last up, passive components get better. This is a write-up of one of each of the new passive components, a resistor, a capacitor, and an inductor by Darshil Patel. And this is just to show you that progress never stops. On one side, we've got resistors manufactured without lead in them, supercapacitors with a new technique that lets them have a super low series resistance, and a flat wound inductor that has a lot less power loss and heating loss too. We all take passive components, resistors, capacitors for granted, but they all do have these subtle real world flaws, and that can always be improved on. Here's a story of 3 of them.
For my first quick hack, I have DropIn Upgrade PCB brings USB-C to DualShock 4. When Sony designed the controller for the PlayStation 4, they put the USB connector on its own little PCB with a ribbon cable going between them. I'd like to believe it was for modularity so they could be easily upgraded, but it was probably just because that was the cheapest way to do it. The advantage, though, is that not only can you easily switch out the USB port if it gets torn up, you can also upgrade to the latest and greatest USB-C. Dogan M95 came up with this little board that actually salvages the flat flex connector from the original board and just swaps out the, I guess, mini USB, whatever the controller was originally using for USB-C. You still have to file the controller case a little bit to fit the newer connector, but all in all, it is a pretty seamless upgrade for the controller, and you don't have to, put a whole new board inside it or anything like that. Next up is single button keyboard, has multiple uses. We've seen these giant single button, you can't really call it a keyboard, but input devices in the past, and they're usually kind of like a novelty thing or just, an excuse to see how big you can print an MX key switch. But this is a little bit different. This one comes from Modular, and there's actually a screen under the button. It's described as a Pop-O-Matic bubble cover by Christina Panos. And not only can you can push it and interact with the computer, but there's different kind of software that you can run on the screen, like a calendar or show live weather or whatever you want to do. One of the examples is you could use the whole thing as rolling like a virtual die. It's certainly a unique peripheral. I would be lying if I said I didn't want to have one on my desk at the moment. And last up is the Hackaday prize entry. This is Stretch Your Day with this 29-hour clock. And we have seen an incredible number of clocks on Hackaday. But even amongst all of those, I don't think we've ever seen one quite like this. The idea here is that you can adjust your perceived passage of time as the day wears on into the midnight hour. So from like 11 o'clock to midnight, you can make the minutes go much slower so that you think the night is longer than it actually is. Of course, the catch is once you hit midnight, then the clock has to accelerate on the other side an equal amount to catch up. The goal was apparently to recreate those childhood feelings of an endless evening after a day that went by too quickly. I know for me, it would just make me think I was getting more done before midnight, but then all the articles would be out of sync when they were released on the site, so it wouldn't do us any good. And also, the clock looks really cool. It uses a wood veneer with LED digits behind it to have this kind of like magical illuminated wood effect. It's a really cool clock among a long history of really cool clocks.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And this week I picked Dan Maloney's Books You Should Read, David Macaulay's Architecture series. And the funny thing is this had its genesis in a podcast a couple weeks ago where we were talking about water mills and the Industrial Revolution. And Dan was like, do you remember that book, Mill? And I was like, oh, yeah, totally. We started reminiscing about this series of books, ostensibly about architecture, covering cathedral, pyramid, castle, mill, also a fantastic book called Underground, which I'll talk about in more detail. But these are just fantastic kind of human scale architecture books. They tell you about how the people built the things and with absolutely fantastic illustrations. And if the name David Macaulay sounds familiar to you, you've probably read his post-architecture book, The Way Things Work. And so if you know that, you know kind of his visual style. But I think it's worth going back to some of these architecture books because, for instance, when I was a kid, I remember reading Castle and, seeing not just how castles are built, but then how all the different parts of a castle kind of function to protect things. And then sometime around then, I think I was in my early mid-teens, we took our first trip to Europe where I actually got to see real castles. And having looked at this architecture book and then walked through the real things was just an absolutely, it's an absolute epiphany for me. Ditto Cathedral, actually. If you are stuck stateside, Underground is phenomenal. It's kind of ostensibly about the buildings of modern cities and skyscrapers with the realization that everything that makes them work is in the foundations. And so it's a crazy, crazy book where he takes the ground away and shows you everything that's going on underneath the city, from like the canals to the foundations that make skyscrapers hold up and stuff like that. It's absolutely fantastic and imaginative and definitely worth a read. Is architecture a Hackaday topic? Is building buildings something we're all interested in? I have no idea. But if you read through these books and you aren't in the end, then I can't help you.
Well, I am not of the correct generation to have come up with these particular books, but I tell you what, I think I wish I was, because the kids books I was looking at were nowhere near as cool as these, and having a 5-year-old right now and spending my evenings reading kids books, I'll tell you the current ones are even worse. I do wish there was something like this when I was younger, because this was definitely right up my alley. The illustrations are awesome. What happened? This is what this is what would have been interesting to kids in the 70s, and now we've reverted to this grotesque oversimplification with bright colors, and I don't know. I mean, that's
I don't think we're talking 5-year-old kids here. I think we're talking 10-year-old, 12-year-old kids.
I got a 12-year-old too, man, and the stuff she's reading is only slightly better than what the 5-year-old's reading. I don't know. There's so much visual detail packed into these images. Even one of the captions, I think Dan says, like, how do you even imagine a scene like this?
Right?
It comes from a special kind of mind for sure.
These are architectural drawings, but none of them are from life. Like when he's, removed all of the soil from Manhattan and is looking at it from underneath, you can't do that. And same with the castle ones and stuff too. No, what you should get for your kids is The Way Things Work. You should absolutely check that out. It's been updated to a lot more kind of modern electronic things as well. I think the first printing, it actually had a good coverage of the space shuttle in it, but it's got a lot of kind of a lot more mechanical things, I would say, than electrical things. But the newer version of The Way Things Work is a really good mix of both. Like if you wonder what's inside a laptop, it's got a cutaway laptop for you.
Yeah, I suppose not a lot of kids today are worried about, how's the grain mill work?
What's inside a 1970s telephone?
Yeah.
I have to say, Joe nailed the art on this one. Ladies and gentlemen, Joe Kim, Hackaday's art director. Holy cow, he completely, just absolutely nailed the David Macaulay style in the Jolly Rancher on the top. That needs to be a poster on my wall.
Well, my pick for this week is Tech in Plain Sight Microwave Ovens. This is from Al Williams, and the genesis of this one, I don't even know that he was proposing it as an article when we were talking about it, but we were doing our weekly call, and Al Williams is always one for an interesting anecdote or tale, and he was like, hey, do you ever notice that every time you turn your microwave on, the table spins the opposite of the way it did before? And no, I had not noticed that because I never really gave it any thought. But the rest of that afternoon, I kept on starting the microwave up, and sure enough, it does seem to bounce back and forth, every time you start it. And we had wondered, is that, intentional? Because, why do they do that? Is there some kind of is there a microcontroller in there that's remembering when the last position was? And as we talked about more, we're like, hey, maybe you should look into this and write it up. So sometimes these articles come literally from our own curiosity about the world around us. And the result is this article that, starts with the history of the microwave. I think most of us have heard the legend or the story where, somebody's working on a magnetron and their chocolate bar in their pocket melted. I think the version I heard was somebody was working on a radar dish or something. I don't know, but I think it's a common enough story, right? Somebody was working on a high energy thing and noticed the chocolate bar in their pocket was melted, and thus was born the microwave. Which always struck me as kind of weird, because if I noticed a chocolate bar in my pocket had melted, I'd be worried about what it did to me, right? That would be my first concern. Not necessarily researching how I can commercialize this thing, but hey, it was a different time. The patent goes back to 45, as Al explains, but they actually were talking about cooking with radio waves even earlier than that. In Westinghouse in 33, apparently they were making toast with radios. It mentioned that if you got into the beam, it would give you an artificial fever, which is a fun way of saying you're being cooked by radio waves. And then it goes into, like we talked about, more than the nitty gritty of how the modern microwave works, the interlocks, which are their own crazy thing. There's like 3 interlocks, and they all have, instead of just being 1 or even 2 things that could fail, like all 3 would have to fail at the same time for you to get the artificial fever, as Westinghouse would say. And then, finally, after going through all that, and post some really cool details and videos about like teardowns of modern microwaves, it gets to the turntable, right? The thing we've been waiting to hear about, and I've been waiting for, I feel like, weeks to hear about. How does the turntable work? And the answer is a little bit anticlimactic. It works because it's cheap to work that way. It's basically it's a synchronous AC motor, and it just kind of spins the way it spins where it stopped in the cycle. When you start it again, it's going to, depending on which direction it goes in. So that was the lesson here. It was not like there's a thing in there that says, hey, every time. It's really just the kind of the mechanics of it. And it's interesting. I did, not that I didn't believe, Al Williams, faultless researcher, I think, but I did look into it myself a bit, and it said that back in the day, when that day was, I'm not 100% sure, it used to be that like the fan would have a belt, and the belt would turn the turntable, so it would always go the same way. And but the belt was like a failure point because the belt could snap, and they decided, okay, at some point it was cheaper to put this little pancake AC motor in there than belt it into the fan, and that started the era of the unpredictable turntable. But there was a time where it always went the same way because it was spinning with cooling fan, which I thought was kind of interesting. Like everything else in our modern life, it was been, other than the lid sensor in your 2019 MacBook, it was all designed to be as cheap as possible. And this is the end result, a mystery that is not so much mystery.
Well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you'd like to follow along with the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, send us an email, tips@hackaday.com. And until next week,
keep on hacking. Oh, really? Oh.
Ask me why. I do not know.
The joys of the computer.
Nothing can't be messed up with software. I think I won't say that.
I was on the wrong track because I could hear it.
Automatic nut sorter? No.
Crews shooting through tubes and stuff. It's amazing how hard it is to find our own stuff. Like, you'd think we would know where this stuff is, but
if I'm gonna do it right, I'm gonna do it right. Why not?
Who wrote this? Upgrade PC Brie? Yeah, PC Brie. That's a cheese, right?
PC Brie.
Hey, God, what are we in? Hour and a half before I screwed up anything that bad. That's not bad.